Hi everyone, I'm Shiji, EVP, Head of Smart Utilities and Infrastructure from Urban Solutions, ST Engineering. I hope all of you had fruitful meetings during World City Summit 2022. The world that we are living in today has undergone tremendous changes. While industrialization and urbanization have helped to improve lives, it has also brought about challenges that we face today, including global warming and climate change. As we speak, we have seen severe heat waves across the world this year, beginning with South America, North America, and now in Europe and Asia. Closer to home in Singapore, we are seeing rising sea level, and is projected to rise by up to 1 meter by year 2100. More than 30% of our land is less than 5 meters above mean sea level. Obviously, we do not have a lot of high ground to turn to. In striving for a more sustainable smart city and estate, we are looking at the 4 R's. First, reduction, to reduce consumption, waste, and carbon emission. Second, renewables, to replace with low carbon energy sources. Third, reuse, build once and use many times, shared by many parties to reduce duplications and wastage. And the fourth, resiliencies, ensure the solution is robust and be able to withstand threats. I shall elaborate and provide some of the use cases for each of the 4 R's, which ST Engineering is able to offer our solutions together with our partners. Reduction. One of the most viable and self-funding projects is the street light replacement program with LEDs and remote light control. LED luminaires can provide up to 60% or even more energy savings for the same amount of lumen compared to conventional halogen or high-pressure sodium lamps. This is substantial if you consider 20 to 30% of the city energy consumptions goes into lighting. With light control and dimming, we can further reduce energy consumption by another 20% with improved service level and less downtime. The return of investment is usually between 4 to 6 years, depending on the energy tariffs. An added advantage is the wireless canopy network overlaid for the remote light control. It can also be used for other sensors or devices in environmental monitoring and advanced metering infrastructure, and I call it AMI in short, for smart water meter reading. Water AMI allows detection of leakages and prevents wastage and revenue loss. The use of smart light for energy savings can also find its ways in buildings. Changing fluorescent light in buildings to LED can potentially provide 50 to 60% energy savings, and in areas such as underground car parks or common areas which are always lighted, motion sensor-based smart lighting can bring about an additional 60% savings without compromising safety and user experience. Another effort in reduction in carbon emission and carbon footprint is through the electrification of vehicles and the use of public transport. Road transportation using gasoline accounts for almost 20% of the world carbon emissions. One of the challenges is the EV charging infrastructure, which is a heavy investment, but is likely to see returns after 5 to 8 years, depending on policies and pricing models. The use of public transport remains the most viable solution for transport carbon emission reduction. And we are proud to be involved in metro rail and intelligent bus transport management systems to improve public transport efficiencies. We have also launched our Airpitant data center cooling system, which combined with existing conventional chiller systems to achieve over 20% in energy savings over tropical data center cooling, and with a payback in less than 3 years. Next, the renewables. Renewables and the use of low carbon emission energy source are the most direct means towards achieving net zero carbon or carbon neutrality. Solar power panels using rooftops of buildings in the land-scarce Singapore, together with energy storage systems to address fluctuations, are by far the most viable. Other locations for solar panels deployment also include water surface in reservoir or sea. Reuse, the ability to build a system or a platform once, share and reuse by many parties to minimize duplications and wastage, hinges on the openness, scalability, and ease of use of the system and the platform. The use of the wireless network canopy overlaid by the street light control can also be used for other sensor applications. This is provided that the wireless network canopy protocol is based on an open standard. An emerging challenge is also the huge amount of data to be processed and stored with the growing uptake of IoT. Now, can sensors and data be shared so that different parties can use them to develop their own applications? The answer is yes. In ST Engineering, we developed the Agile Smart City Operating Systems, in short, Smart City OS, to provide a centralized platform to manage key assets, be it sensors or devices, and also the data. A highly scalable integration platform that can be applied and deployed from buildings to city. It allows the collection of data from various vertical systems to provide a single source of truth and insights for facility performance management and operation optimization. Stakeholders can make use of the common data to digitalize and automate workflow and processes across systems, leading to efficiencies, savings, cost avoidance, and better service level. An example is the use of data analytics and AI. It is an opportunity to reconsider some of the maintenance practice regime, from preventive to predictive and proactive maintenance, to reduce unnecessary preventive maintenance, but yet give focus of what is of high priority for better outcome. The system is designed with open standards and APIs and facilitate easy onboarding of devices and assets using a low-code or no-code approach. It is a platform designed for reusability. Last but not least is resiliencies. Resiliencies forms an integral part of sustainability, and in particularly to address cybersecurity in the converge of IT and OT systems against vulnerability threats. The use of AI and machine learning for abnormality detections allows faster response to potential threats, which in turn helps to reduce security risks and breaches. In summary, we strive to achieve for a more sustainable smart city and estates through the 4 R's of reduction, renewables, reuse, and resiliencies. This solution can be found on our website, agilesmartcities.com. I hope you have a fruitful journey in achieving a sustainable smart city in your cities. Thank you.
My name is Chi Chong. I am the Vice President of ST Engineering. Today, the objective of my presentation is to share with you how ST Engineering leverages on technology to help Singapore achieve its sustainable urban mobility development over the years. First, we will discuss about the different stages of ITS development, trend, and focuses as urban mobility development evolved over the years. Next, we'll review some of the new mobility challenges in recent years and how emerging technology are explored to address such challenges. ITS, it is a key enabler for sustainable urban mobility. It is the application of advanced and emerging technologies in transportation to improve mobility. Singapore has always in the top ranking globally for both Smart City or Urban Mobility Ranking Index. One of the key success factors is that Singapore has always been at the forefront when it comes to adoption of advanced and emerging technology, especially in the area of ITS, to improve its mobility services. This slide here gives a high-level overview of ITS development trend and focuses over the years as urban mobility evolved. In the early days, ITS development and focus were mostly infrastructure reliant, with main focus to improve operation efficiency. After implementing a great deal of ITS system, which is mostly operated in silo, we started to integrate this isolated system to allow better interoperability and integration to provide seamless operation between the different systems and improve productivity. Subsequently, greater emphasis was placed on data collection, analytics, and the availability of relevant information on the move, as well as to share this information to different stakeholders. And in the later stage, with the emerging of new mobility challenges, we continue to explore and leverage on emerging technologies such as mobile devices, artificial intelligence, big data, etc. to help us to address these new challenges and also provide better mobility service to the commuter. In the next few slides, we will review and discuss in more detail on some of these key ITS systems deployed at the different ITS development stages. Now, we know that Singapore had implemented several strategic policies as well as ITS systems to reduce traffic congestion in the city. This includes the Vehicle Certificate of Entitlement or COE, as well as the Congestion Charging or ERP system. This strategy has proven to be effective to reduce congestion during peak hour. However, in the event of traffic incidents such as an accident as shown in this slide here, this event can result in severe traffic congestion that may last for hours if not managed efficiently. Strategies like COE or congestion charging will not help in such event. Study has shown that non-recurrent events such as accident contributes to 60% of congestion in the city. Therefore, efficient management of traffic incidents becomes critical to keep our road network congestion-free. In 1998, the first EMAS system or Expressway Monitoring and Advisory System was implemented along the city expressway with the main purpose to manage traffic incidents efficiently to reduce traffic congestion as the result of this incident. EMAS make use of various sensing communication technology supported with artificial intelligence decision-making process to help operators to manage the route network and to ensure minimum delay due to traffic incident or event. The key components of the EMAS solution are illustrated on the right in this slide here. Independent study has shown that EMAS enable faster clearance of accident from an average of 32 minutes to 17 minutes after the deployment of EMAS. Such faster clearance of accident result in several benefits. These include economically, saving of more than 30 million a year due to the reduce of traffic delay, environmentally, a reduction of carbon emission from 22 to 8 tons for a minor traffic accident. and socially improve safety and provide better travel experience to the road user. At the private sector, GPS-based advanced fleet management was adopted to help taxi fleet operators to improve their operation efficiency as well as to improve their customer service. The use of this advanced fleet management solution was also expanded to improve the operation efficiency for other fleets. Now, over the years, as the authority implemented a whole bunch of ITS systems for various applications and purposes, this system, however, were mostly implemented and being operated in silo. The full potential of this system were not fully exploited due to the isolation nature. However, by integrating this silo system together under one single platform, where operator can operate the different systems under one unified operation and user interface, not only allow interoperability between systems but also improve efficiency and productivity. In early 2000, an integrated operation platform, or simply iTransport, was implemented for the integration of various ITS subsystems and external agency systems. It provides a unified operational platform for island-wide traffic management and operation control. The deployment of iTransport enabled the authority to improve its traffic management KPIs such as improvement of incident handling time, reduction of accident duration, as well as the reduction of traffic jam duration. Going beyond the infrastructure-based ITS system, we now started to pay more attention to how to leverage on information to enhance our mobility services. For example, by providing accurate and timely traffic congestion information to driver can help to ease congestion as driver will choose a different route to divert away from the congestion gridlock. To ensure accurate, timely, and reliable traffic information, the Traffic Information Hub, or simply TI Hub, was implemented to process, analyze, and store information obtained from different sources both internally and externally. This processed data can then be shared with other stakeholders. To the public, the processed traffic information and advisory are disseminated via different media channels such as the wearable message sign, traffic information portal, mobile devices or mobile apps, message sign for the parking guidance, as well as multimodal travel information via mobile apps. Today, one of the persistent mobility challenges that we are facing is that we always have to compete the limited land we have on this island with other sectors in Singapore, this including land use for the housing, seaport, airport, commerce and industry, as well as parks to provide us a better quality of life. Besides this persistent challenge, we are now also facing new challenges such as the changing commuter expectation and norm. This can be attributed to the demographic and societal change, desire for freedom of movement, more connection, faster and more comfort mobility, and also concern to impact to environment. In anticipation for the new challenges and also new opportunity as a result of emerging technology as well as the growing popularity of smart devices and social media, the Land Transport Authority and the ITS Society of Singapore has since developed a new ITS strategy plan called Smart Mobility 2030. This plan provides guidance for advancing the ITS technology and application to strive for more connected land transport community. 4 focal areas were identified: informative, interactive, assistive, and green mobility. In the next few slides, we will discuss more use cases of ITS deployment for each of these focal areas. For informative, we work with one of the taxi company, ComfortDelGro, who is the largest taxi operator in Singapore with more than 20,000 taxis plying the road of Singapore, through the use of big data analytics where each driver profile are analyzed based on his historical transaction information. When a customer makes a call to book a ride, now instead of searching and sending requests to the nearest driver, the system will instead analyze the driver profile and identify which driver who is most likely to accept the request. This solution greatly enhanced the booking pickup rate for the ride booking. Hence, it enhanced commuter ride booking experience by reducing the average booking time for the taxi, a more efficient operation for the taxi operator. Now, being able to efficiently and accurately detect traffic incident is critical to mitigate traffic congestion due to incident. Traditional automatic incident detection technique has been reliant on traffic parameters obtained from conventional traffic sensor for the detection of traffic incident. The disadvantage of such approach is that sensors are usually installed only along major corridor, as it is not economical to provide full coverage of sensors throughout the road network. Today, the wide adoption of social media, it is now possible to include crowdsourcing to fill the gap of existing traffic sensor coverage. Using such big data and together with artificial intelligence, the detection rate and capability of the traffic management system can be greatly enhanced. Now, traffic prediction estimates the traffic state in the future time based on the real-time information and historical traffic data. Accurate traffic flow prediction is increasingly essential for successful traffic modeling, operation, and management. Today, big data, artificial intelligence with deep learning techniques is capable of constructing complex traffic models based on real-world data. Big data sources such as weather, social media, together with traditional traffic data has been proven to deliver improved prediction performance when processed using AI deep learning techniques. The next focal area, interactive, that is to enhance traveler experience with smart interactivity. Due to the constraint of land use, one of the key policies in Singapore to manage traffic congestion is to reduce the use of private car and attract public transport ridership. The key strategy to attract public transport ridership is to improve service quality for the public transport system. So, an advanced fleet management solution not only have to improve efficiency, but the need to ensure service quality is becoming important, or what we call it performance-based bus fleet management. This performance-based fleet management solution has since been adopted for the management of more than 5,000 buses in Singapore for the bus contracting model adopted here. Benefits of performance-based fleet management is that it makes public transport more responsive to changes in ridership and commuter needs, provide more reliable services, less waiting time, and improved quality of service. Another use case to enhance traveler experience with smarter interactivity is the smart car park solution. Smart car park solution using emerging technologies such as mobile apps, mobile payment, EV charging management services, etc. to provide an all-in-one convenient and seamless parking experience for the driver. In 2020, the smart car park solution was implemented for the NTU or Nanyang Technological University campus parking facility. It is the Singapore's first barrier-free car park system. It provides better parking experience for the driver with faster entry and exit and easy and convenient payment services. As part of alignment to the future mobility and address the new challenges, we collaborated with Transport Authority, Research Institute, and with industry partners in providing autonomous vehicle solution to meet the unique mobility needs of Singapore. As shown in this slide here, the partnership with local authorities and Sentosa Development Corporation, the first on-demand autonomous shuttle bus public trial on Sentosa was launched in 2019. This autonomous bus provides on-demand shuttle service for the tourists and commuter on the island. Commuter can download mobile apps to book their rides, and various other autonomous bus service trials were also conducted in other locations and cities in the last few years. As part of green mobility strategy to promote green public transport and adoption of electric vehicles, ST Engineering developed its vehicle electrification service to convert combustion engine vehicles to full electrical vehicles. As well, to complement the smart parking solution we discussed earlier, Electric vehicle charging management service can also be included to provide electric vehicle driver an all-in-one service that cater to their parking as well as EV charging service needs. Well, with that, I would like to conclude my presentation here today. If you have further questions, you can contact us through this email address here. Thank you.
Urbanization creates opportunities for cities to enhance the quality of life of its people, but it does come with its own set of challenges. Now, as cities accelerate their digital transformation, how can they fully harness technologies and innovations for data-driven insights and address the impact of urbanization? So we are here now at the World Cities Summit Expo, and I'm heading over to the ST Engineering booth. So let's find out how cities can become more connected, resilient and sustainable with the ST Engineering suite of smart city and mobility solutions. Let's go. We're here at the ST Engineering booth, so let's have a chat with the subject matter experts to find out more, shall we? Hello, nice to meet you. Could you tell us more?
A large part of our portfolio includes offering solutions for the built environment and infrastructure management of cities, estates, and buildings. These solutions digitalize infrastructure, optimize operations, minimize energy consumption and waste, and enhance user experiences. We help customers to drive the dual outcomes, which is to increase productivity and achieve sustainability goals.
Now, when we look at smart cities and estates, what are some of the key drivers and priorities of the stakeholders?
The three key drivers are sustainability, connectivity, and security. For sustainability, people typically ask the questions such as, is the building green by design? How energy and water efficient the building is? And what's the carbon emissions? For connectivity, we are looking at the seamless and efficient data connectivity, and they are looking at whether there is an end-to-end data, end-to-end process integration. And for security, we are looking beyond OT security and into OT security. So with all that, everything can be integrated together into a single platform that's analytics driven by insights, and that is our Agile Smart City OS.
Can you tell us more about your Smart City OS?
So Agile Smart City OS is a highly scalable platform that allows the end users to manage the IoT devices at the city level, estate level, and even down to a building level. Now, what Agile Smart City OS does is that it takes in the different subsystems and different communication protocol from each subsystems, ingests it, and standardizes it into a single language. At the end of the day, what we want the end users to achieve is end-to-end process integration and also to achieve a single version of the truth. So for example, if you were to look at ST Engineering Hub, this would be what we're looking at, the leaf monitoring system. These are the actual data for the smart leaf monitoring system. We have things such as total trips, total cycles, trips per day. And if you want to look at where the leaf is exactly in the building, you can double click here and it will show you where the leaf is. Or if you want to say that, look, I want to look at what are the buildings, right? What are the rooms in the buildings, what's the temperature and all that, that can be done as well. From the view here. Right, you can look at, for example, we have a server room. You can show things such as its temperature, the humidity, wet bulb temperature. So you can manage things from an energy perspective. You're going to look at energy consumption and all that. Right? And if you're going to look at the room itself, it's also possible. There's a screen to show you what the room actually looks like. Right? So end of the day, Agile Smart City OS is a living platform. Every day it takes in new information from the data that it has, and it allows the building owners to make better and more informed decisions as the day passes.
Thank you so much for sharing.
Addressing congestion issues and ensuring fast response to incidents on the road has always been a challenge for many cities around the world. Although major cities use a wide range of sensors for traffic management, Many of the subsystems often work in silo and cannot provide a real-time overview of the traffic situation. Our AI-powered Agile Urban Traffic Management System offers a single platform that unifies multiple traffic sensors and subsystems for optimal traffic management. Leveraging on artificial intelligence and big data analytics, our system provides actionable insights and intelligent support that improves responsiveness to traffic incidents. It does that by automatically detecting a road incident quickly and generating suitable response plans to ease congestion and improve travel time and commuter experience via smoother vehicle flow. These powerful capabilities translate to enhanced situational awareness for traffic authorities, proactive traffic management, and faster response to traffic incidents, as well as better travel experiences for road users.
Now, with so many traffic data and disparate systems involved in traffic management, how does the traffic operators monitor the thousands of roads in a city?
Basically, the system reduces the need for operator intervention. Our system's integrated dashboard provides a quick analytics-based overview of the traffic situation across the city, supported by live data feeds and past trends. It automatically highlights critical areas and alert operators, reducing any tedious manual eyeballing experience monitoring by the operators. It also provides a full situational awareness for the operator through the integrated dashboard and multi-viewer. This is represented by a GUI map of the traffic system while integrating multiple traffic equipments for intuitive approach to a specific system, a location. The system automatically monitors and detects alerts to improve response time.
Now, there was an earlier highlight that this is an AI-powered traffic management system. Could you tell us more?
Yes, one of the newest key features include the ability to forecast traffic flow for proactive traffic management. The system is able to predict traffic from 5 minutes to 1 hour in advance with a high level of accuracy and is able to be changed in a 5-minute interval. This foresight capability allows traffic managers to act early and mitigate congestions early. The AI in the system also enables operators to resolve traffic incidents quickly. By considering the various outcomes via traffic simulation, the system recommends the best incident response plans. It enables them to manage the incidents and tasks within the shortest time possible. This is very crucial as every minute saved in detecting and verifying the incidents is equivalent to 5 minutes reduction in recovery time.
How does the system come up with the response plans?
As a baseline, the system relies on historical data and past traffic plans executed by traffic operators for reference. From there, it will assess the various possible outcomes that can be taken in consideration with the information from the various traffic data sensors to generate a few traffic plans. From these plans, it will be further validated with the traffic simulation engine to generate the best outcome possible and recommended for execution by operators.
How would your solution benefit cities that have existing traffic management systems and developing cities?
As technology progresses, more traffic sensors and subsystems will become relevant for cities with an expanding traffic network. With diverse traffic systems implemented over time in cities and the influx of big data, it is essential for cities to leverage on an integrated urban traffic management system to harness AI, data analytics, and IoT, and to allow operators to proactively predict and manage traffic, have faster response time by improving monitoring and detection of incidents, and to disseminate real-time information quickly to road users. Over at ST Engineering, we have implemented our AI-driven intelligent traffic management system in cities such as the Middle East and in Asia. Our strong domain and experience in providing land transport solutions around cities around the world has enabled more than 65 million commuters and motorists to travel more seamlessly while contributing to a more connected, resilient, and sustainable transport ecosystem.
Thank you so much.
Transportation is one of the major sources of greenhouse gas emissions, and junctions are where most traffic disruptions and delays occur. With the growth of cities, there's a need for intelligent systems to help manage the complexity of junction control so that we may improve road network efficiency for a sustainable, livable future. Smart Digital Junction leverages emerging technologies like big data analytics and artificial intelligence to help cities manage congestion effectively. With an algorithm that optimizes signal timings, as well as a user-friendly platform, we help operators and traffic engineers achieve smoother traffic flow, leading to reduced time wasted at traffic intersections, as well as a greener city.
What is Smart Digital Junction and how does it benefit transport authorities?
The AGIL Smart Digital Junction is an advanced traffic signal control system that forms part of the Smart Traffic Management Solution Suite developed by ST Engineering. So, it comprises 3 components. As you can see over here, we have the central management software over at the Operator Control Center. This is used for the management and monitoring of intersections, and it uses operator-friendly interfaces and AI assistance to simplify junction control. Next, we have the traffic control algorithm, which determines the traffic timings at the intersections. It takes in real-time traffic data from sensors installed at the roadsides. It is distributed across edge processor units that are installed at the junctions, and they are coordinated by an algorithm in the central management server. This allows the components to all work together to optimize traffic timings across the entire network, leading to reduced number of stops and hence reduced fuel consumption. And finally, of course, we have the traffic signal controller, which switches the traffic lights based on instructions from the traffic control algorithm.
What makes the AGIL Smart Digital Junction Suite different from other conventional junction management systems?
Conventional traffic signal control systems rely on extensive traffic statistics collection as well as manual data entry to set up the computer models for optimization. These models have to be updated when traffic patterns change. Such systems are also less responsive to unexpected traffic disruptions, such as congestion caused by road accidents. For Smart Digital Junction, we integrate advanced sensors such as LiDARs, which provide richer sources of information. This allows us to leverage sense-making and machine learning to adapt to changes in both long-term traffic patterns as well as short-term traffic flows. This removes the need for laborious traffic data collection as well as data entry, leading to better performance with less effort.
Now, with emerging technologies such as V2X, how does Smart Digital Junction prepare cities for the future?
Conventional traffic signal control systems are limited by legacy requirements, which make them harder to upgrade to support newer needs. Smart Digital Junction, on the other hand, interfaces with controllers through the use of edge processor units, which act as an adapter for controllers as well as sensors. This edge processor unit also allows us to integrate V2X technologies, allowing us to provide features like priority signaling and platooning. Because these edge processor units integrate different types of sensors, it also provides a more versatile upgrade path for more advanced sensors in the future without having to resort to hardware interface layers. This positions cities well for the future needs. Of course, when you talk about being future ready, we also want to help operators and traffic engineers perform more effectively so that they can cope better with the growth of cities. Conventional traffic signal control systems rely on outdated interfaces such as command line based or text based displays. They also tend to be complicated and require extensive training to operate. Smart Digital Junction, on the other hand, is designed to be simple to use. So let me show you more about our platform. Here we have our signal center, which is used for the entry of data for our system. It uses graphics as well as intuitive controls like drag and drop to simplify the process. Next, over here, we have our map viewer, which is used for the real-time monitoring and control of intersections. It uses GIS-based displays as well as data visualizations to provide a more intuitive look at what is happening at the intersections. Finally, we have our Performance Center, which provides dashboards and data analytics tools for operators and traffic engineers to better track and understand the different KPIs at the junction, so as to better inform and improve long-term traffic engineering strategies.
With so many benefits built into the Smart Digital Junction, would you be able to show us some of its key capabilities in action?
Sure, let me show you a quick demo of our system. This here is our map viewer, which is what operators at the control center use to monitor the traffic situation as well as operational status of junctions in their region. Our system is continuously monitoring traffic data coming in from the junctions and comparing it with historical data to identify anomalous patterns. Over here, the system has highlighted that there may be unexpected congestion at this particular intersection. You as an operator may then want to take a closer look at the junction. This over here is our junction view, which provides more detailed information such as the operating mode, current signal timings, as well as equipment fault statuses. You can also take a look at traffic KPI charts to better understand the traffic status. With AI assistance as well as intuitive displays, we help operators quickly determine the course of action so that they may respond swiftly to help ensure smoother traffic flows. To wrap up, Smart Digital Junction leverages real-time traffic data as well as big data analytics and artificial intelligence to achieve better junction efficiency. This is also done with the aid of our edge processor units, which integrate V2X technologies like priority signaling. And they also offer cities with more flexibility in terms of upgrading their sensors in the future. Last but not least, our central management software makes it simple for operators and traffic engineers to operate. This all combined together help to improve traffic flows, reducing congestion and shaping the future of a connected, sustainable land transport ecosystem.
Thank you so much for sharing. It was definitely very enlightening.
Alright, so e-motoring as a service, or EMAS, is essentially a one-stop motoring services platform that drives the setup of a collaborative and sustainable ecosystem for the different stakeholders, namely motorists, the mobility service providers, and last but not least, also the transport authorities. So what we see globally is that electrification and digitalization are twin trends that are changing how people move in cities globally. But however, this leads to a new set of challenges for our stakeholders. So what EMAS does is that it offers a brand new motoring experience by offering motorists a single application to access different motoring services, and for different mobility service providers, a chance to leverage digitalization to widen their access to different customers. And last but not least, for transport authorities, access to insights to improve their planning for regulatory purposes.
How does e-motoring as service accelerate vehicle electrification?
So electrification brings about a more sustainable cities. However, a lot of countries presently, they are implementing incentives for the adoption of electric vehicles, but a lot of companies, they still face challenges in making this shift. And this is because charging takes time. So it's unlike the traditional internal combustion engine where vehicles can just pump the petrol and go. Companies are concerned about the impact on their operations, their business, and also their driver's schedule. So what EMAS does is that it offers drivers and companies access to information of chargers and also charger information on the go, so that not only are they able to plan their operations in advance, they are also able to improve the operational efficiency. In the long run, what EMAS aims to also do is to provide them insights to improve their businesses.
Besides driving electrification for fleet operators, how can e-motoring as a service benefit motorists and motoring service providers?
Alright, so the core value proposition of EMAS is to provide seamless convenience for its stakeholders. So for example, for motorists itself, what we aim to do is to integrate all of the different motoring services onto a single platform for the motorists. So for example, if before a motorist were to set out, they are able to look up the different services that they need, for example, plan their charging beforehand, or maybe even their vehicle maintenance. And when they reach their destination, they are also able to benefit from location-based promotions such as meal discounts in their location. So this provides a seamless convenience for them. So this is also a problem that we have identified according to user studies, where currently a lot of motorists express dissatisfaction at having the need to access different applications just to search for the motoring services that they require. So obviously, to provide a better motoring experience, we also require a variety of different service providers. So this would include parking operators, charge point operators, and also maybe even vehicle maintenance companies. So what EMAS does is that we allow for faster onboarding of these customers, and not only would they be able to have an overview of their operations, they are also able to quickly harness digitalization to get access to new and a larger pool of customers. So for example, for charge point operators, what they are able to do is to view, monitor, and also manage their charging network so as to drive a better service level and uptime and leading to an increased customer satisfaction for their users.
How does the e-motoring as a service approach meet a city's needs for a more sustainable future transport ecosystem?
So IMAS also has a wealth of data and insights that can benefit authorities. So for example, if charge point operators were to integrate all of their charging network information onto IMAS, so authorities will not only be able to understand the service levels of the different companies, but they are also better able to incentivize these companies to provide a better experience for transport authorities. So in the long run, not only are they able to draw insights to better improve the grid network planning or even the transport network planning, they are also able to fulfill to identify unfulfilled demand to better place the different chargers. So this will allow the cities to move towards a more sustainable future and to adopt electrification better and faster. So this is what IMAS can do, and in general what we view is that electrification will lead to a paradigm shift in cities globally. So it wouldn't be a zero-sum game where a single company can say that I want to service the whole country or even the whole city, because it will be very costly. So what IMAS views is that it will instead be a collaborative approach where different companies and different stakeholders can come together to bring about a brand new motoring experience for motorists. So essentially, IMAS wants to deliver a one platform and one mobile application concept to its motorists, and we hope that you will be able to join us on our journey.
Thank you so much. That was fantastic.
Ever wonder what makes a city smarter? Backed by a global track record of over 800 smart city projects in more than 150 cities, here at ST Engineering, we empower connected, resilient, and sustainable smart cities using AI and advanced analytics to provide a real-time operational overview of your city's multimodal transport network, ensuring your metro lines are always running at its optimum efficiency. Conveying real-time information to commuters throughout their journey. Enhancing commuter experience and ensuring passenger safety at all times. We provide full asset maintenance visibility to keep your metro system running efficiently and safely. We ease urban congestions with AI-powered urban traffic management system. Optimize the city's bus operations to improve service levels and making car parking an easy and seamless experience for motorists. Supercharge your transition to a smarter and greener future with a comprehensive suite of electric vehicle charging solutions to support your vehicle electrification journey. Revolutionize the future of smart mobility with autonomous transport solutions. Digitize your city infrastructures, scalable from building to city, to achieve sustainability targets towards a net zero carbon future. With more than 1 million smart streetlights deployed throughout the world, we reduce streetlight downtime, improve energy savings, whilst providing optimal lighting for road safety, and saving up to 60% in energy with smart estate lighting. We enable 24/7 remote lift status monitoring, providing real-time visibility of lift operations, helping to improve operational efficiency with advanced water metering infrastructure. Our end-to-end smart security solutions protect cities, people, and assets 24/7, from perimeter protection, biometric access control, video surveillance and analytics, to integrated security management platform. We safeguard digital and physical infrastructures to create safer spaces throughout the world. Harnessing technology and innovation, we empower connected, resilient, and sustainable smart cities. helping to improve quality of life and paving the way for a more livable and sustainable future.